Hi Dara, or Dara, however you pronounce it. Sorry, I should have known that that was you, DT. Anyway, the first question asks, solve graphically. What that means is, what they want you to do is they want you to graph the left-hand side of the equation. And if I were to graph the left-hand side of the equation just really quick, it would look something like this. Really, you want to do that in a calculator. You also want to graph the right side of the equation. And if I were to graph the right side of the equation, it's going to look something, maybe not exactly like this, but it'll look something like this. Now, what you want to get out of this graph is where those two graphs are equal. Where they're equal is where the two graphs intersect each other. So the goal here is really to graph two different sides of an equation and find where those two functions intersect each other. This actually requires a calculator or something. So what I'm going to do is I'm going to send you a video on how to both graph these things. Well, hopefully you know how to graph these two things on your calculator by now. But how to use a function that finds where two things intersect. There's another way to do it. You can, right off the bat, subtract 5 from both sides of this equation. Set it equal to 0. Then, if you did this, so this is a totally different method, maybe not totally, but it's a different method. If you graphed this left-hand side, and I don't know exactly what it's going to look like, so I'll just make something up. I think it might look something like that. Now what you're trying to find is where this graph equals 0. That graph equals 0 right there and right there. And sometimes that's a slightly easier problem to solve. You would also need to use a calculator or something on the internet. I guess if it's on a test, you need to use a calculator. So I can show you, I can send you a couple links that show you how to do that as well. However, what I should say is, while this question asks you to solve this graphically, it's an online class, and you can solve it algebraically as well. This is an equation that you can solve. It's just quadratic. So if you want to do this algebraically, quadratic formula is just going to give us x equals, let's see, negative 5 is going to be positive 5 plus or minus the square root negative 5 squared is 25 minus 4 times a, which is 2, times c, which is 4, all over 2a. And you can simplify all of this and plug it into your calculator, and you'll get two answers because there's a plus. That'll give you one answer, and the minus, if you use the minus, will give you another answer. And those two answers that you end up with should be the same two answers that you get if you solved this graphically, using this technique or using this technique here. So I'm just kind of throwing that out there. I mean, the computer's not going to know the difference whether you solved something graphically versus algebraically. So again, I'll send you a couple of informational videos as well on how to use your calculator to find these points. And I'll move on to the next problem. Let's see, the next problem is number 79. And this question asks you to find the zeros of f of x equals 2x squared minus x plus 4. Alright, so to find the zeros of a function, all you have to do is set the function equal to 0. And in this case, you're asked to solve this algebraically. So that means you have a quadratic and use the quadratic formula. So negative b, that's positive 1, plus or minus the square root of negative 1 squared, that's 1, minus 4ac, all over 2a, 2 times 2. And you can simplify this, and it should go pretty quickly, hopefully. So this is 1 minus, what is this? That's 8 times 4 is 32. So 1 minus 32 is negative 31 over 4. Anytime you get a negative under the square root, you now know because of chapter, I believe it was earlier in this chapter, wasn't it? You can call this the square root of 31i. So basically you get rid of the -1 inside the square root, and you call it an I outside the square root. All that over 4. And I think, I'm not sure, yeah, that's it. They ask for exact answers, so that's it. If you wanted to give two different answers, one answer would be 1 plus square root of 31i over 4. And the other one would be 1 minus square root of 31i over 4. So this answer is what you would enter if they ask you to, I guess, separate your answers with a comma. And this answer would be fine on a test that was graded by hand. So the last problem is number, what was it? Number 97. Number 97 is the trickiest one of the bunch. They give you a hint though, and the hint is to replace, make a substitution, u is the square root of x. Okay, good. Now, how are we going to make this substitution? Well, clearly you can see that you have a square root of x right there. So this middle term is going to be minus 3u, and the minus 4 is going to stay. I have a question though, what happens to this x? Well, you would have to notice that to get x in this substitution, you'd square both sides. So you could get x is u squared. And then x right here becomes u squared. And now you can kind of see why we made that substitution in the first place. We made this substitution because this now turns into a quadratic. And you know how to solve a quadratic. You can use the quadratic formula, and if possible, and in this case it is possible, you can even factor. In this case, you can factor this into u minus 4 and u plus 1 equals 0. What you're told, I don't know if it's in this section or in the previous section or class even, the way that you solve this is you split this up into two pieces. U minus 4 equals 0, and u plus 1 equals 0. Anytime you have two things multiplied equal to 0, you can split it up into two pieces. That's going to give you really easily u equals 4 and u equals -1. You're almost finished. The problem is nobody really wants you to find u. The whole goal in this original problem was to find what x is. So how can we get back to x? Well, what we have to do is use the substitution. One more time. Right from the very beginning, we said that u is square root of x. So really we have square root of x equals 4 and square root of x equals 1. How do you get x by itself now? Well, you square both sides. You square the left side and you just end up with x. Square the right side and you get 16. And using that same method, you get x equals 1. And those should be the two answers to that problem. Well, I hope that this helps. Let me know. There were a lot of problems here, and of course I go kind of fast. Feel free to pause the video whenever you want and rewind and listen to it again. But let me know if you have any more questions.